Intro, Black hole mergers. Black hole mergers defying our understanding of physics. What's up with that? Well, nobody doesn't love black holes, or at least doesn't love talking about them. Avoid them if you see one coming. Back in my day in graduate school many moons ago, we know how to make black holes as the endpoint of stellar evolution. How does that work? Well, the sun after another 5 billion years has been around for 5 billion. So after a 10 billion year lifespan, it's going to run out of fuel in its core. And then it will release its outer layers of gas into space and lay bare a dense core that we call a white dwarf and create a very beautiful nebula in space. By the way, we'd be in the middle of it. Would be long dead by then, but would be a very beautiful nebula to other star systems if they train their telescope on us. That's one way a star can die with the mass of the sun. But how about stars that are 8 or 10 times as massive as the sun? Well, they have a very different fate because much more is going on in the core of those stars than is going on in the core of our sun. Above a certain mass, the endpoint of a star is not just gently release the outer gases. The endpoint of that star is it runs out of fuel. Its core collapses and undergoes total spontaneous nuclear fusion, blowing the guts of the star to smithereens. It can outshine the entire galaxy in which that explosion takes place. We call these explosions supernovae. Typically at the end of a supernova, what's in the core of that is a dense ball of neutrons. In keeping with astronomical naming and nomenclature, we call that a neutron star. Very dense, much denser than the white dwarf left over from when the sun dies. What happens if the star is 10, 11, 12, 15 times the mass of the sun? Well, it has so much mass that when the core collapses, it keeps collapsing. The collapse in a way is stronger than the explosion that would otherwise take place. It collapses in on itself. Bada bing. Thus is born a black hole. That star would have lost some of its mass along the way. But what got folded into the black hole? 6, 7, 8, 9, 10 times the mass of the sun. We call those stellar mass black holes. And we expect them to be dotting the galaxy where stars had been born, laid out their lives and died. The giants in the center of the galaxy. Towards the end of my time in graduate school, there was suspicions that the centers of galaxies might harbor a black hole. Not just any black hole, a supermassive black hole, way more massive than the one you'd get from the endpoint of stellar evolution. So we started looking. This predates the Hubble telescope. Now got the best ground-based telescopes, the best spacehorn telescopes. In some galaxies we find a supermassive black hole. And in keeping with astronomical extrapolations, many of us said, me included, if we have a supermassive black hole in these 3 galaxies, and these are the first 3 galaxies we've even looked for them, then clearly every galaxy has a supermassive black hole. Why not presume that and then go check? And that's what we did. Bring in the Hubble telescope, which had very good vision down into the centers of galaxies. Sure enough, every galaxy we have ever observed in its center has a supermassive black hole. Even we have a supermassive black hole. The one in the center of the Milky Way is 4 or 5 million times the mass of the sun. How about Andromeda? The drum is almost our twin. It's another grand spiral galaxy, and it's the closest big galaxy to the Milky Way. It's a little bigger than us. But does it have a supermassive black hole? It sure does. And what's its mass? 100 million times the mass of the sun. We don't know how to make them yet, but clearly this is a thing in the universe. Alright, so that sent people to the drawing board. Well, the center of the galaxy is quite a busy place. There are gas clouds that'll lose energy that can dip down into the center, get eaten by these black holes. These black holes can also attract stars and flay them as they come too close. There are mechanisms for these black holes in the centers of galaxies to grow by dining upon material that wanders too close. So we started modeling that, and we now feel comfortable with supermassive black holes in the centers of galaxies. We even learned that the more massive the galaxy is, the more massive the black hole is. That kind of makes intuitive sense. You still want to be able to explain it. The itty-bitty galaxies, they have little itty-bitty black holes. Itty-bitty supermassive black holes. Okay, that gives us 2 categories of black holes. Stellar mass black holes and supermassive black holes that you'd find in the centers of galaxies. And that was a peaceful existence for decades. Alright? There was no other reason to think we'd have black holes of any other size. New black holes. And then they started showing up intermediate mass black holes. Black holes that can't be the end of stellar evolution. We know stellar evolution. That's the triumph of 20th century astrophysics. Decades studying the birth, life, and death of stars. We got that. You're not going to get a 20 or 30 mass black hole that comes out of a star that has died. Alright? And we got the supermassive black holes. Suppose you find a black hole that's 30, 40, 50, 100 times the mass of the sun. We have no idea how you make them. So let's return to the drawing board. The drawing board is an active thing that's always up in the office. Okay. Is there a way to make an intermediate mass black hole? That is still unresolved. Could it be that you make binary black holes that are 10 solar masses each or 8 and then they merge and the two masses combine and then they find another black hole mysteriously somehow and they merge? Or is this the product of mergers, or is there its own process that can come together and make these from scratch? We just don't know. We got top people working on it. Top black hole people. That's a good thing. I can't wait to find out what the best model is for creating these black holes that had no previous way to understand how they came into existence. Aliens did it. The frontier of science. An active area of research. A headline might say we have to new physics. Okay, maybe to describe it as though that's a problem. No, it's an exciting time. That's what being on the frontier of science is all about. Being stumped. Let's gather at our conferences. Let's write our research papers. Let's do the peer review thing. Let's figure out what's going on and move forward this frontier of modern astrophysics. So that is what's up with that. Neil deGrasse Tyson for Star Talk bidding you to keep looking up. Breaking news. Astronomers just detected the most massive black hole merger ever, and it's forcing us to rethink everything we thought we knew. These black holes fall into the mass gap, a range that current models of stellar evolution say shouldn't exist. Add in unusually high spins near theoretical limits, and our standard formation theories start to unravel. If confirmed, this would change how we think black holes form, grow, and collide. But before we rewrite the textbooks, we need clarity. That's why we think Ground News is one of the most important platforms out there right now. They built an app and website that helps separate speculation from science. With one swipe, we can find original research and highly factual sources alongside the world's perspective to see what's been established, what's being debated, and what facts are missing. Founded by a former NASA engineer, it has the same precision you'd expect for a space mission, but it works like a smarter version of how you're already staying informed. That's why we've partnered with the platform for years now, so our viewers can follow every major development from physics to deep space and more for nearly half the price. Just go to ground.news/star or scan the QR code to get the same unlimited Vantage plan we've been using for $5 a month. A small investment towards our mission of helping the world understand the cosmos and the science driving it all.